We've learned that we can do a hypothesis test to test a claim about a population parameter, like a mean value or a proportion. But anytime that you want to test a claim to see if a true difference exists between two population parameters by using two independent samples, you can also do a hypothesis test to test a claim for a difference, but you can also test the claim by building a confidence interval. So in this video, I'm going to show you three different scenarios and explain to you how to interpret the confidence interval that you get so that you can make a conclusion about the null hypothesis. So referring back to the freshman 15 article, let's assume that population 1 represents the weight gain for freshman men, and population 2 is the weight gain for freshman women. Then mu1 would be the mean weight gain for the freshman men, and mu2 would be the mean weight gain for freshman women. Okay, this is the claim that we're going to test. We're going to test the claim that on average, freshman men's weight gain is simply different from freshman women's weight gain, and we're going to use a significance level of 0.05. So to test this claim using a confidence interval, the first thing that you need to do is make sure that you pick what's called an appropriate. So what's an appropriate confidence level? Okay, so what are we going to test it at? Are we going to test it at a 99% confidence level, 90%, 95? How do we determine that? And the answer is to figure out what is appropriate, you need two pieces of information. We need to know our significance level, okay? And then we need to take a look at the alternative hypothesis. So the alternative hypothesis will let us know if we have a one-tailed test or a two-tailed test, okay? So let's go ahead and take a look at what the alternative hypothesis is. So the claim that we're trying to test is to see if there is just a difference in men's weight gain and women. So that means that we're testing for mu1 not equal to mu2. And since this alternative hypothesis has that not equal sign, this means that we have a two-tailed test, okay? So what does it mean to have a two-tailed test when we're doing a hypothesis test? When we're doing a hypothesis test, and here I'm going to draw a t-distribution with degrees of freedom of 39. And the reason why I'm using 39 is because we have some sample data on the top left here. And we can see that from our sample data, we have two samples that are of different size. So you take the smaller of the two, and the degree of freedom is n minus 1. Okay, going back to what I was saying before, right? Let's take a look at this t-distribution for a two-tailed test. At the center of this distribution is the null hypothesis claim. So the null hypothesis claim is that mu1 is equal to mu2. And if mu1 is equal to mu2, then the difference, so if men's mean weight gain and women's mean weight gain are the same, we expect that when we subtract to see a difference, that difference is going to be 0, right? Okay, so two-tailed test means that we have a critical region on the left tail and a critical region on the right tail. The area of the critical region on the left tail and the area of the critical region on the right tail is our alpha split equally. So I'm going to have alpha divided by 2 on the left, alpha divided by 2 on the right, and so 0.05 divided by 2 is 0.025, 0.025. Okay, when we build a confidence interval to test the same claim, okay, our confidence interval is also going to be this bell-shaped curve, and our error rate in the tail has to match up with our error rate when we do a hypothesis test. So again, because this is a two-tailed test, when we build our confidence interval, the appropriate area, shaded in yellow here, is this area that I'm shading in between our critical regions. So this right here determines this area that I'm shading in yellow. It determines our confidence level. Okay, so let me make sure I spell that correctly. Confidence level. Okay, so how do we calculate the confidence level? It's the shaded area under the curve that's in between the tails. So since on the left we have 0.25 and on the right we have 0.25 together, that adds up to alpha, which is 0.05. So our confidence level is going to be simply 1 minus the area in red. So 1 minus 0.05. So this means that an appropriate confidence interval or confidence interval would be a 95% confidence interval. Okay, So 0.95 is 95%. Okay, so if you take a look at my screenshot on the left here, you'll see that I went ahead and did a two sample interval test on the calculator, or two sample t interval on the calculator. I put in all my sample data, and then you have to put in the correct confidence level. So again, you're not going to be told what the confidence level is. You have to figure it out based on the significance level that you're testing the claim at, and then you have to decide if this is a one-tail test or a two-tail test. So the results of the two sample t interval, you'll see down here, we get this confidence interval, which is telling us that the limits of the difference between men weight gain and women weight gain, the difference is anywhere between negative 4.79 to negative 0.49. So we are 95% confident that the difference in the mean weight gain between men and women is between these confidence limits. So I tell my students the easiest way to interpret the confidence interval is to just draw yourself a number line, okay? And then at the center of your number line, put 0. 0 is where there is no difference. So that means when mu1 is equal to mu2, the difference is 0. Our confidence interval says that we're 95% confident that the difference is between, and my number line is not to scale here, but my lower limit of negative 0.47 up to my upper limit of negative 0.49. So notice that this confidence interval completely misses the null hypothesis claim that the difference is actually the same. So anytime that the confidence interval, right, does not contain 0, so we say it does not contain that 0 value, this means that we are going to reject the null hypothesis. Okay, so the reason why we're going to reject the null hypothesis is because we just said that we're 95% sure that the difference between men's weight gain and women's weight gain is actually going to be a negative value and not 0. So because 0 is not a possibility, right, the likelihood of it being 0 is not likely based on our confidence interval, we would reject the null hypothesis that the mean weight gain for men and women are the same. So in the last example, we talked about how do we decide what is an appropriate confidence level to know what type of confidence interval we're going to build to test the claim. So right here, we're looking at the same exact claim. We want to test the claim that the average, on average, freshman men's weight gain is simply different from freshman women's weight gain. So again, two-tailed test, meaning that we're going to split alpha equally on both sides of the tail, leading us to a confidence level of 0.95. So we would build a 95% confidence interval, which you can see that that is what I put in for our confidence level for the two sample t interval in the calculator. But this example is slightly different because I want us to suppose that we change some information here. And let's suppose that the sample data below, instead of having a mean weight gain of 2.6 pounds for the men, let's assume that it turned out that the sample data showed that it was 3.5 pounds with a standard deviation of 4.8. So notice I made those changes in the calculator. And I'm just making up this as an example so that we can talk about the results and interpret it. So once we do the two sample t interval, you can see here that because of the sample data, because we have different sample data in this example, it led to a different confidence interval. So the results of the confidence interval here is from negative 3 point, so let me highlight it, negative 3.87 up to positive 0.47. So again, to interpret your confidence interval, draw yourself a number line. Make sure you put 0 at the center, and at the center, 0 means the difference between mu1 and mu2 is 0, so implying that they are the same. And then here we would mark our confidence interval. It goes from, and again, this is not to scale, but I know that negative is on the left side of 0, and then the upper limit is positive 0.47. So here you can see that this confidence interval, it does contain mu, which is also the null hypothesis claim. So here the confidence interval says we are 95% confident that the mean between men's weight gain and women's weight gain could be as low as negative 4 point, or as low as negative 3.87 pounds up to positive 0.47 pounds, which means that it contains the difference of 0, meaning that this is a possibility that the mean difference could also be 0. And we're 95% confident that could be the case. So in a situation like this, you would say that since our confidence interval contains 0, right? That means that the null hypothesis value could be true with high level of confidence. We would then we would fail to reject the null hypothesis. Okay, so different conclusion than in the first example. Okay, kind of same example, but this time I'm going to change the claim just a little bit. So notice here, the claim that we're going to test is we're going to test the claim that on average, freshman men gain less weight than freshman women. Okay, so same significance level that's tested at a 0.05. And we're going to test it by building an appropriate confidence interval. So again, we have to ask ourselves, what is an appropriate confidence level? Okay. And okay, so what is an appropriate confidence level? Is it going to be a 90% confidence interval, a 95, 99? What is it going to be? It depends on two things, your significance level, which here we're testing it at a 0.05. And the second thing is that alternative hypothesis. Okay, so that alternative hypothesis. So here we want to see if men's weight gain is less than women's weight gain. So that means mu1 less than mu2. And then notice that this leads us to a not two tail. This is a one tail left. So this is a one tailed, right, left tail test. Okay, so what does that look like if we were doing a hypothesis test? So if we were doing a hypothesis test, we would use a t-distribution, again, with degrees of freedom of 39. At the center, we would find that the difference between mu1 and mu2, if the null hypothesis value is true, then that difference would be 0. And then here we're testing the claim that men's weight gain is actually less than women, or that's the same thing as saying women's weight gain is more than men's. And let's see where the significance level is. So, okay, left tail test means that all of alpha is going to be on the left tail. So all of alpha is going to be on the left tail, 0.05. And then now we have to build an appropriate confidence interval so that we can test this claim. So again, when you build a confidence interval, the critical region has to be the same. So if we were doing a hypothesis test, this right here is the critical region on the left tail because this is a left tail test. When we're building a confidence interval, you have to take into consideration the left tail and the right tail, and that area has to match up. Now, I know my drawing is not to scale, but that means that on the right side, when we're building this confidence interval, on the right side, alpha is also 0.05. So now we have to figure out, well, then what is the confidence level when we build that confidence interval? Okay, so we're going to get that confidence interval by taking a look at what the area is in the yellow shaded region. So what is the area under the curve that is not the critical region? So to find that, I'll write it down here. Oh, let me use blue again. So to find our confidence level, I'm going to take 1 and subtract, right? Notice that I have alpha on the left and alpha on the right. So that's the same thing as 2 times alpha, 2 times 0.05, which is 1 minus 0.10, which leads me to a 0.90 or 90% confidence interval. So notice that when I did my 2 sample t interval, I made sure to change my confidence level to 0.90, and then you can see the results of the confidence interval below. So here we are 90% confident that the difference in weight gain between men and women is going to be between negative 4.365 to negative 0.8347. Now let's talk about how to interpret this. So again, draw yourself that number line. Put 0 at the center, meaning that if the null hypothesis claim is true, we expect mu1 to equal mu2 if that difference is 0. But here we're 90% confident that the difference is actually between negative 4.3, I'll just round, 37 to negative 0.83. Okay, so again, notice here there. Notice here that we do not have the null hypothesis claim in our confidence interval, so 0 is not in there. So since 0 is not in confidence interval, right, we would reject the null hypothesis. So we're saying that we are 90% confident that the difference between men's weight and women's weight is actually a negative number. So notice that this is all negative numbers, more specifically, negative numbers between negative 4.37 and negative 0.83. Okay, so what does that mean? Well, if we go back to the alternative hypothesis up here, when we make the statement that mu1 is less than mu2, what this really means is, in terms of differences, if we calculate the difference, we're saying that mu1 minus mu2 is some value less than 0. And then what do we know about values less than 0? Those are our negative values. So so it makes sense that we would have this confidence interval down here. And because 0 is not in there, we reject the null hypothesis, and we would conclude that we have sufficient evidence to support the original claim, which is that alternative hypothesis, the claim that on average men actually gained less weight than freshman women.